Hi guys, this is Bob, N9KR in southern Indiana, and I just thought I'd put together a video to show a little bit about my almost all homebrew CW station. Thought it might be of interest to some of you guys and gals out there, and maybe spark a little bit of that homebrew spirit for anybody that's kind of been thinking about building some of their homebrew stuff. I started about 10 years ago. I've actually been a ham for over 50 years. Can't believe it, but that's how long it's been, since 1961. But I started about 10 years ago kind of on a homebrew kick, and as a lot of folks started with a simple transmitter on 40 meters, and then kind of expanded from there and incorporated some additional features and enhancements, and built receiver and some auto tuners and switching stuff, and ended up with a pretty workable solution for me. And as usual, it's never completely done. So I'm not going to try and go into a lot of detail, but just wanted to give you a flavor for what I've got, and maybe we just kind of we'll go from there. I may put together some additional videos in a little more detail on some of the specifics of the station. As I said, it's almost all homebrew. I think the only thing that you can see in the video here that's not may be this Drake speaker. We're simply using that for the speaker, for the receiver, and of course the keyboard up there that we use for the keyer that is homebrew, and for storing messages and doing a lot of contesting and things like that. So let me just highlight the individual pieces here real quickly, and then maybe I can even go into just a little bit of detail on this video. Over here on the far left, there's a 15-volt power supply on the bottom down there. It's basically just built around an LM317. It's variable, and we use it for most of the transmitter voltages, the low voltages in the transmitters. Above that is a little control head that actually provides voltages from a homebrew set of 3 PC power supplies. You can't see there on the floor back there. Put together, and I tap off the various voltages. It gives me 17 volts or 28 volts or up to 36 volts, and I use those higher voltages for the high-end voltage supply in the little homebrew amplifier here, which is based on, there's a couple of FET transistors in there, the IRF 510s, which are really cheap, and this is a very close emulation of the WA2EBY, I think, amplifier, very popular a number of years back. And it works well, gives me about 40 to 50 watts out on most of the bands. In the top amplifier over here is a little, it's an EB63 amplifier, homebrew. Puts out about 75 to 100 watts, and that's the one I use in the system. It's broadband. I follow it with low-pass filters for transmit, and it works real well. I just leave it in the system, and whenever I need a little extra power above the QRP level, we kick that on. And actually, I'm powering that with a power supply that was taken from an HP server. Reconfigured just a little bit, but it will give me that 13 volts at gazillion amps. I mean, it's good for up to 50 or 60 amps, which is way more than I need. It's behind the wall in the next room because of the loudness. There's some loud fans in that guy. But I just hit the little AC power switch over here to turn that on and off. That's in the system. And down here next over we have a little manual switching arrangement to switch in the various transmitters. I have transmitters for QRP transmitters, all homebrew, but for 30 meters, 40 meters, 15 meters, 20 meters, and 80 meters. And I can basically just switch in the VFO and the output with this box so that I can apply that. Power is applied all the time with 12 volts, and the keying circuit is connected all the time. Those transmitters themselves are, this green box is a 30 meter transmitter. The box above it has both the 20 and the 15 meter transmitters. Box over here on the bottom that I'm pointing to has the 80 and the 40 meter transmitters. And they're all very similar. The transmitter design is very similar in each one. I'll go into more detail on those later in another video. little low-pass filter up here that I haven't got in a box yet that we switch between the filter that I use for the higher bands and the lower bands on the transmit side. Next over we have this is the 80-40 meter transmitter on the bottom. This is the receiver on the top. It's a SA512 single conversion heterodyne receiver. Enhanced quite a lot from some of the earlier designs that I experimented with. And I've got a variable IF in there. There's a 4-stage crystal filter, a 9 megahertz IF, and it's a con filter, 4 crystals in there. Each one of them has a variable capacitance in between that we control with a DC voltage up here, and that gives me the variable selectivity, which really works great at the IF level. I also have built into that a active audio filter that's based on the L-Craft, I think it's the AE1, or can't remember the model number, but it's built, it's modeled after that design. It has two positions of selectivity, and it works as well as in conjunction with the variable IF. I'm on 40 meters now. We can hear somebody on here talking. There's the IF turned down considerably. Up here we have a SCAF filter that I built into an old, most of these boxes were something else originally, so we used what boxes I had, what chassis I had available, and kind of repurposed them for the various rigs. So most of the labeling on the front is not applicable, aside from what I've added with my own labels. So this is the transmitter on the bottom for 80-40, the receiver. Then there's a SCAF filter up here that I built. It's another form of an active audio filter, and it works pretty well. We don't use it a whole lot, but I can kick it in when I need to, and it gives me more selectivity. Above that, I have a selectable attenuator. On the receive side, I can select 3 or 9 dB attenuation, or both. It also has 2 bandpass filters built in. Again, this is on the receive side for 20 meters and 40 meters. And those are all switch selectable from the front. Come in very handy to get rid of any of the local mixing components that get mixed in from some of the local strong FM stations and QRN that's in the area. Mostly at night, comes in real handy. In addition to that, I have added on a couple of bandpass filters external to this box. There's one for 15 and there's another one in the back for 30 meters. Someday I probably need to get those all incorporated into one box. And that's on the receive side. Here's the Drake speaker over here next. Here's the DDS VFO that I built. Very, very handy. It's based on the AD9840 chip. Actually, the complete control module is available on eBay. They're down as cheap as $5 now, and that works great. It's controlled with an Arduino microprocessor and some great code that was written and then enhanced a little bit for my own application by me. But it was written by Ross. He's got a website called Ladderline. He's a ham up in New England, and I can't think of his last name right now. But great software. Gives me all the flexibility I need. It's broadband. I can go from 0 to 50 megahertz or higher with this configuration. And I've got switching built in where I'm switching both the transmit and some of the receive functions, so it's almost automatic. I control it all from this VFO. Over here we have a QSK box. If you can see it in the video, a QSK box. It's that I built. It's based on a Wes Hayward W7ZOI design in one of the earlier handbooks. It's good for 100 watts. It uses pin diodes for switching, and it gives me completely quiet, instantaneous QSK for CW. And for me, being kind of a CW buff, QSK is really important. That fast break-in. So it works great. Basically, the receive side is always on, and then the switching happens with each DIT or each DAW from the keyer. And it's quiet and just works really good. I'll give you a little example here. We'll just move down to an open frequency on 40 and just send a QRZ, or are you busy? and question mark correctly. But you can see how it cuts off the receiver smoothly and it's nice and quiet. Works good. We have a All-Home-Brew CW keyer over here, which is another Arduino project, and some code, some fabulous code that was written by Goody K3NG. He's got a website with all kinds of work on that particular project. This keyer, I built actually two of the systems, modified the code a little bit myself, modified the hardware just a little bit. In one of my other setups, I have a keyer on a Drake station, but it's basically the same keyer. Works great. Lots of memory, lots of features and functions. To the far right over here, if we can still keep it in the video, maybe, is a Homebrew auto tuner that is another Arduino project. It works pretty darn well. That's the most recent completed project, and we can tune pretty much any antenna down to about a 1.5 SWR. It also includes a built-in power meter, built-in SWR function. We're pretty happy with that. The code that drives that was a compilation of code, open source code that we've borrowed from and worked with from a number of contributors, and we're real happy with that. As usual, most of these pieces are in kind of a continual state of evolution, but we're getting closer to being pretty comfortable with the setup. It's pretty automatic, and we can switch bands quickly, and just about, even with simple verticals and an inverted V, which is the extent of my antenna system, work just about anybody that I can hear anywhere in the world. So we're pretty pleased with it. With that, let me go ahead and probably stop this video at this point, and we'll see how this goes, and then maybe we'll work on some more detailed discussion of some of the individual projects, including maybe a look at some schematics and some lessons learned as we build and develop those projects. Thank you very much.